Hello guys, welcome to our math lesson, and today's topic is for the methods of factoring polynomials and the finding its roots. And the first subtopic is polynomials with integer coefficients. You will be able to recognize polynomials with integer coefficients and their roots. Okay, theorem number 1. Let this polynomial be a monic polynomial. Monic polynomial means that a0 is equal to 1. If a0 is equal to 1, we can say this polynomial monic. Where a1 and etc. an are integers. Okay, what does mean integers? The integers includes all negative whole numbers, 0, and all positive whole numbers. Remember this. And n is greater or equal to 1. Then any its rational root is an integer. Okay, second one. Let this polynomial be a monic polynomial, and a1, an are integers, and n is greater or equal to 1. If the root a of this polynomial is integer, then root a is a divisor of constant term an. Divisor is bölgüç. Okay, consequence of theorem 2, integer roots of a polynomial with integer coefficients can be only the divisors of its constant term. Okay, look at this theorem and read and try to understand. Okay, look at this example. Find integer roots of the polynomial this. Okay, what we do? First of all, look at this one, 5. 5 is our an, yes? And the divisors of the constant term are 1, minus 1, 5, and minus 5. Yes? 5 has 4 divisors. Okay. Let us find the value of polynomial at these points. We put these numbers to this polynomial, yes? Look, if we put 1, here will be 1 to the 4 power plus 2 multiplied by 1 cube minus 2 multiplied by 1 square minus 6 multiplied by 1 plus 5 equal to, if you solve this expression, you'll have 0. Okay, next one. If we put minus 1, here will be 8. 8 is not equal to 0. And let's put 5. Here will be 800. And it also is not equal to 0. And the last one, if we put minus 5 to this polynomial, we will have 360. From this expression, we can say 1 is the root of polynomial, whereas minus 1, 5, and minus 5 are not. And we can factor polynomial in the form p of x is equal to x minus 1 multiplied by q of x. Here our k is equal to 1. Okay, let us factorize polynomial p of x using synthetic division. We draw a table, yes, and write in the first column coefficients of our polynomial, and in the second column we just find coefficients of our q of x. Okay, we know that a0 is equal to 1 and the c0 is also will be equal to 1. And then by this formula we just solve, we just find c1. c1 is equal to 3, and like that we find our coefficients of q of x. And then we can write like this. Our polynomial is equal to, this one is q of x, yes, and this one is our factor, yes. If we multiply these two expressions, we will have our polynomial. And okay, now we need to factorize q of x. Divisors of constant term are 1, minus 1, 5 and minus 5. Here is our constant term, yes, minus 5. And the divisors are these numbers. There is no need to check minus 1, 5 and minus 5, since they are not roots of polynomial, of our polynomial. It is enough to check for 1. Okay. Cube of 1 is equal to 1 cube. We just put to this x 1, yes, and it will be our root. Using again synthetic division, we draw a table here and write our coefficients of q of x, yes. By solving this one, here will be c1 is equal to 4, c2 is equal to 5, and the c3 is equal to 0. And then it gives us this expression is equal to x minus 1 multiplied by x squared plus 4x plus 5. This one we get from this table. Trinomial x squared plus 4x plus 5 has no real roots, therefore polynomial p of x has two integer roots, 1 and 1. Okay, if you solve this, if you equalize to the 0 and solve, we don't have roots, okay? And in conclusion, our first polynomial, this one, we can write like this: x minus 1 multiplied by x minus 1, and then the last one is here, this one. Okay, we just find our roots, our integer roots, and they are 1 and 1. I think you understand these informations. See you on the next video. Goodbye.